Welcome to Get Your FRQ On. This question is from 2010, Form B. It's question 3, and it is calculator active. In the question stem, we have a cylindrical swimming pool, height 4 feet, radius 12 feet. We are given that the pool contains 1,000 cubic feet of water at time t equals 0. And on the interval from 0 to 12 hours, water is being pumped into the pool at a rate given by a function p of t, cubic feet per hour, and there is a table of specific values for p of t at various times t. And during that same interval from 0 to 12, water is leaking from the pool at a rate r of t, and r of t is given with an equation. In part A of this question, we are asked to use a midpoint Riemann sum to approximate the total water pumped into the pool between 0 and 12 hours. The total amount of water pumped into the pool over the time interval from 0 to 12 hours is given by the integral from 0 to 12 of p of t dt, which, using the table and the midpoints to calculate the sum here, we eventually get 660 cubic feet of water being pumped into the pool between t equals 0 and t equals 12 hours. In part B of this question, we are asked to find the total amount of water leaked out of the pool during that same interval from t equals 0 to t equals 12 hours. So the total amount of water that's going to leak from the pool over the time interval from 0 to 12 hours would be given by the integral from 0 to 12 of r of t dt. And since this is a calculator active question, we can use our calculator to calculate the value of that integral. The integral from 0 to 12 of r of t dt is equal to the integral from 0 to 12 of 25e to the negative 0.05 t dt, which after using our calculator turns out to be 225.594 cubic feet of water. In part C of this question, we are asked to approximate the volume of water in the pool at t equals 12 hours to the nearest cubic foot. The total amount of water in the tank at t equals 12 hours is given by the integral expression 1000 plus the integral from 0 to 12 of p of t dt minus the integral from 0 to 12 of r of t dt. Keep in mind, this accounts for the fact that there's already 1,000 cubic feet of water in the pool, and the fact that water is being pumped in and water is being leaked out. It just so happens that the value of the two integrals above were already found in parts A and B of this problem, so we already have values for those which we are going to be expected to use in this calculation. Using the values that we already know, 1,000 plus 660 minus 225.594 is 1,434.406 cubic feet. So to the nearest cubic foot, at t equals 12 hours, there was 1,434 cubic feet of water in the pool. In part D of this question, we are asked at what rate the volume of water is increasing at t equals 8 hours, and then to determine how fast the water level is rising at t equals 8 hours. Since the volume of water is being affected by water being pumped in and leaked out, the rate at which the volume of water is increasing or decreasing must take those rates into account. And we get v prime of t is equal to p of t minus r of t. This implies that v prime of 8 is p of 8 minus r of 8, which is 60 minus 25e to the negative 0.05 times 8. Since this is a calculator active question, we can use our calculator to evaluate what that is, although I don't think for this question you would have to. I think if you just had the exact answer, that would also be accepted. Not sure how easy that would be for calculations for the rest of this question, but it would be right for this one. So using our calculator to calculate v prime of 8, we get 43.241 cubic feet per hour. Using the fact that the volume of the pool is pi r squared times the height, we can conclude that the rate at which the volume is increasing or decreasing over time is 144 pi times dh dt, which implies that dh dt is dv dt times 1 over 144 pi. So dh dt specifically, when t is equal to 8, would be 1 over 44 pi times dv dt specifically at t equals 8. And since this is a calculator active question, we can use our calculator to do this calculation, and we get 0.095 feet per hour. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.